In this video, we will look at forces, how to resolve forces, and the basics of the force friction. Consider this force with magnitude F acting at an angle of alpha to the horizontal. So using basic trigonometry, we can resolve this force at an angle into a horizontal and vertical component. Let me label the horizontal component as H and the vertical component as V. So H, which is horizontally, we can use basic trigonometry. So cos alpha will be the adjacent, which is H, over the magnitude of the force F. So the horizontal component of this force will be F cos alpha. And similarly, we can do this to the vertical component. So the vertical component of the force F will be F sin alpha, and the horizontal component will be F cos alpha. Let's take a look at this inclined plane problem where we are asked to find P and R in terms of W. So let me break down W into two of its components that are perpendicular to each other. This angle will be 90 therefore. So in order to do that, we should find this angle which is unknown to us. Or else you can find this angle, but I'll be using this angle. This component of the W is perpendicular to this inclined plane. Going on to the diagram, we can see that this angle is 90 because W is vertically downwards and this is the horizontal ground. So therefore this will be 90 minus theta, and as I told, this component that is perpendicular to the inclined plane, so therefore this angle will be theta if you do the math and angles here. So now we know this unknown angle to be theta, so we can have our component that is parallel to the plane to be W sine theta, and that is perpendicular to the plane to be W cos theta. So therefore now our perpendicular force will be aligned with our R force, reaction force. So R will be W cos theta, and since this ball is in equilibrium, P will be the force that is opposite, because in equilibrium sigma F is equal to 0 by Newton's second law. So therefore P will be W sine theta when you consider parallel to the plane. So let's move on to friction. So friction is a force that acts between two rough surfaces. So the maximum friction of an object is given by mu r. Mu is the coefficient of friction, which is the ratio between friction and reaction force. So in order for an object to move, the force that pushes or pulls the object should be greater than friction. Think about it. If friction is not at its maximum, then the object will not move. So let's say we are told that the object is in limiting equilibrium. This means that the force that tries to push or pull the object is equal to the friction force, maximum friction force. That means mu r. And whenever an object is not at limiting equilibrium and it's stationary, that means the friction force is less than mu r. So the friction force is less than the maximum friction. So let's try out this problem that combines all the ideas we went through in this video. So we are given this box that is moved with a force P with an acceleration of 0.3, and the coefficient of friction between the box and the ground is 0.1. So always remember, in the exam you will be mentioned if the surface is rough or smooth. If the surface is rough, there is friction, and if the surface is smooth, there is no friction. So in this question we are asked to find the value of P. So how do we approach this problem? So let's just consider the horizontal component. We are told that it is moved with a 0.3 acceleration horizontally. So there is a resultant force horizontally. So we can resolve the force P in a horizontal component, P cos 45 minus this friction force, which is at the maximum. As I mentioned earlier, maximum friction is always happening when an object is moving. So that is going to be mu r. 0.1 r is equal to the mass of the box, that is 10. Acceleration is 0.3. And then let me consider vertically. So when I consider vertically, we are never told that the box moves vertically up or down. So therefore the box is in equilibrium considered in a vertical sense. So therefore P sine 45 plus the reaction force. Do not forget the reaction force. So plus the reaction force is equal to 10G, and therefore now we can solve these two simultaneous equations to obtain the value of P. And there we have it. I solved the simultaneous equations and obtained P is equal to 16.5 to 3 significant figures. So we have to always apply Newton's second law in these types of questions. So here 10 times 0.3 is actually sigma F equals ma, which is Newton's second law for resultant force. So yeah, that's it for this video, and I'll see you in the next one.